Thank you very much for joining. So as announced, the agenda for today's meeting is to discuss how we are going to proceed with the N-3 launch. So now I have prepared slides to explain how to prepare for it. Then this is a process I propose. So there are 4 steps. Like the one, we need to set our objectives. Even though we already know what the N-3 rocket will be, but again, it's important to reflect the objectives again and set the objectives. Then secondly, we need to identify our remaining tasks. So for the first batch interns and the second batch interns, they have made a great progress, and most of the tasks has been addressed. But I understand that there are some issues for every team. So we need to identify what is remaining tasks and try to address those issues. Next, we need to have a solid timeline because our time is very limited and the schedule is very tight, because we expect, I explain it in the later slide, but we expect to have it launched in November. So let's say we have 2 months to go. And as most of the members are not working as full time, so our time is very limited. So let's prepare the strict timeline and comply with it. Lastly, we have to define the on-site operation. The on-site operation means what we are going to do in the Seattle. So the procedure of launching our rocket in Seattle. That is something we have not done in the previous year. So it caused a lot of kind of issues. So we need to identify each member's role, like what each member is supposed to do, when. So in which order. So this is very important that we have learned in the previous struggle. So as I mentioned, we are going to expect to have it launched in November and late November. This is still to be determined. That will be discussed with KSA, and we need approval from the KDF. Then the thing is, the reason for November is that we are considering that there are some final year students working on N-3 rocket. And for example, the one student from mechatronics, who is Bob, is preparing to install the tail fin control system, active fin control system. So that should be tested in N3 launch. Also, some students from telecommunications are working on the telemetry system. This is also should be tested with the N3 rocket. Also, Stephen is working on the unscented Kalman filter. So we appreciate if we can test it on board. Okay, so considering those aspects, we propose to have it November, and we need to fix a date with Kenya Space Agency in early October at latest, because we need to have kind of ample time for the preparation and seek for the approval. So talking about the goals, as we already know, there are major goals or common objectives. So our expectation is we have an apogee of 2,000 meters, and we need to have safety recovery of the rocket using a parachute. So that is something that recovery teams has been working on. Next, we should have improvement from our N2 rocket. Even though we have done the video transmission using the digital camera, but this was disturbed, I think, because of the telemetry issue, we have not been able to achieve the full video transmission. So we should improve it in N3. Also, the N3 flight controller and avionics PCB didn't have onboard data logging system. So which was actually an issue when we tried to recalculate the apogee using the flight controller. We were not able to do it. So this time, we need to have onboard data logging. And this is actually what has been addressed by the recovery team in first batch. And also, as I mentioned, there are final year students working on the N3. So active tail fin control by Bob, and the telemetry system by Jones, Ruth, and Safa, and unscented Kalman filter estimation by Steven. And I forgot to mention that, but the June is working on the wireless power transmission. So this should be also tested. Now, what we need is following. So definitely, your commitment and devotion is required because as we don't have a full-time intern now, so each team member's commitment is very important. Also, everyone must have your responsibility, meaning I'm going to explain it later, but we are going to create a list of the tasks, and we are going to assign the person in charge, and everyone must be, such a person in charge in some tasks. So, and that is what I meant. And of course, we cannot rely on, other independent person. You have to work together and help with each other. That is very important. And I want to reboost this forum, and I'm going to increase the frequency of this meeting. So the day will be discussed, but for this week, I propose to have it on Sunday as well. This will be a short meeting to discuss the progress. The reason is, as you know, maybe the meeting once a week is not enough to keep track of progress. So yeah, that is my proposal. And then last minute work is not allowed. That is my message, which have been seen in the last N-2 rocket launch. So we should be optimistic, and we shouldn't give up until the end of the day, but we should plan ahead and work in advance to avoid the last minute work. And finally, as I mentioned, the on-site operation, preparation for such an on-site operation is very important. So we should rehearse our operation, maybe at latest 1 week before the launch. As I mentioned, a very strict timeline we have. So this time, I want to say something like this. So we need to drop some objectives if the team think it's difficult to achieve at this point. Meaning, because we have limited time and resource, even the manpower, so we have to limit our focus so that we can achieve all the goals. So if you think it is too difficult or it is too challenging, I think we can modify our objective and reset our goals, then follow that goals. Okay, that's it. And so I propose to have a next meeting at 5 p.m. on Sunday, which is 24th. So I'm going to, so after this presentation, I'm going to explain what will be the next tasks. And the task is to identify the remaining tasks. So we are going to list up on the Excel sheet. Also, we are going to configure the GitHub projects so that everyone knows the current progress. So on Sunday, we are going to finalize such a remaining task Excel sheet and also complete the GitHub projects. And next week, Wednesday, I think it should be adjusted based on the availability of the members. But I proposed to have a meeting at 1 p.m. Considering most of the members will be available at this lunchtime. So we will also check the work in progress. So that is the brief. And let me go to the Excel sheet or spreadsheet. So this is something we are going to complete by Sunday this week. Now, the major agenda is the rocket. And so basically, we are going to clarify what kind of hardware we are going to prepare, how much, by when, and also what kind of software we are going to complete. So basically, we are going to list up the remaining or outstanding tasks in this sheet. And the major point is that how many rockets we are going to launch in this time. So this is just a proposal. And since we have a fiberglass body and aluminum body, if we have 2 pieces per each, we can set 4 rockets for the N-3 launch. But this is just a proposal. We can customize. We can even increase, or we might need to decrease the number. And my biggest concern is the number of solid rocket motor we can fabricate until the launch, by launch. So I think I need to ask an opinion from the solid propulsion team. I see Daniel online, so maybe can you comment on that? So how many solid rocket motor casing can be fabricated and tested? Daniel or any solid propulsion team members, if you can comment.
Okay, moment.
Yeah.
One motor. The one is about 90% completed, but the tools we have at the machine shop don't work. And it were to be completed, we need assistance.
Okay, so thank you. So one casing is complete, almost being completed, right?
One casing is totally completed, but the other one is about 90% completed.
The others means how many?
We have a total of 2 casings at the moment, but one isn't totally completed.
Okay, so I understand. Okay, we have 2 casings. One is totally completed, and one is almost being completed, which is 90%.
Yeah.
All right. So in case of having 2 more, do you think is it feasible?
I don't think because the boring tools we are using at the machine shop are what led to the problem of not completing this other one. There are no effective boring tools unless we were to search for something better that will machine the aluminium better. And also we don't have 2 other aluminium blocks to use.
All right. That is noted. Okay, so I think for the 2,000 meters cross motor, 2,000 meter apogee motor. I think we can have 2 at most. This is a kind of how to say a bit pessimistic or I don't know, the realistic assumption. But the maybe I want to ask for the opinion from airframe team. So how many airframes have we already made so far?
Hello.
Hello.
Yeah, I'm Jeremiah speaking on behalf of the airframe.
Yes.
So we have 2 complete fiberglass airframes, and the 3 aluminum airframes are waiting for the rivets, but they're already cut into pieces, and we're just waiting for the assembly of the whole tube.
Okay, thank you very much. That is good. So now that is a good news. And I'm thinking we can, okay, this is a proposal for the solid propulsion team. Because we have many things to test, right? Like telemetry, like flight control, like recovery. So if we can have N-2 motor this time, again, we can launch the 5 rockets in total, right? Cindy. So yes, so maybe one for, okay, I think this should be discussed, the combination. For example, yeah, I'm saying like this is one combination. Let's say so it is also depending on the resource of the solid rocket motor team, solid propulsion team. But the, yeah, this is just one proposal. So if it's difficult to fabricate 2,000 meters apogee motor, we can still downscale it because we have not achieved the full objectives, all of the objectives in the N-2 launch last year. Yeah, so this is just a recap from the last year. Maybe Dr. Mshiri, what's your opinion?
I'm a bit lost. Just repeat the question. What was the question?
Oh, sorry for that. Okay, maybe I
Yes.
should have asked solid rocket propulsion team again first, but because so now we are discussing how many rockets we are going to launch in the next launch, and the most or the major constraints is how many rocket motor we can fabricate, especially casing. And since the solid rocket motor team have achieved 2 of them, one is completed and one is almost completed. But it would be difficult because they are not working as full time anymore. So it would be difficult to fabricate the same casing, the other one. So instead of making a bigger rocket motor, how about making the N-2 solid rocket motor, which is downscaled, so that we can launch 5 rockets, because we have 2 KNSB rockets ready, and 3 of the aluminum airframe is being ready. If we acquire the rivet, we can fabricate it. So not to lose our opportunity, I'm proposing to develop the N-2 solid rocket motor again, so that we can launch the 5 rockets in total. Maybe ask for your opinion, Dr. Mashiri.
Okay, then I think I agree with you. The development time for the N2 is shorter, so maybe we could just complete the N3, the one that is 90% complete. Then I don't know how long it will take for them to come up with the N2 size frames. I don't know how long that will take.
Right. So,
yes, if we're able to establish, then we can establish whether we get 5 or
right.
Yeah, it's just about time. Sorry.
Okay. Okay.
How long
Thank you.
it will take?
Yeah. Thank you.
Okay.
I'm seeing June is raising her hands. Please go ahead, June.
Good afternoon, all.
Good afternoon.
I think I just have a concern or a question with regards to moving to N2. Would we not then need to change or scale down our target apogee, considering N2 was slated for 500 meters?
Yes, right. Yes, that is true, because we are using the N3 airframe with the N2 solid rocket motor. So definitely the apogee will be downscaled. But the thing is, we can still confirm some of the functions, like you see, for example, flight control, telemetry, and recovery. Considering the fact that we have never been achieving the successful recovery, I think having more rockets, even though it has a shorter range, but it would be a good idea to launch multiple or more rockets. Yes. So let me ask again, Daniel. So how do you think about having N2 rocket motor? 3 of them.
I don't know what the opinion of the others is, but I think I would also agree with it. In fact, even for launching, first of all, we start with the N2, and then once you're able to establish what maybe the problems would be, by the time you're getting to launch the N3, a few things can be corrected here and there. So I think it's a good idea to have the N2 motor.
Right. Yes.
In fact, I think it's advisable to have it. Yes.
Yeah. Yeah. Thank you for your comments. Yes. So since the N2 motor was designed for 500 meters, so because this time our airframe is getting bigger and heavier, so definitely the apogee will be less 500 meters. But anyway, solid rocket or solid propulsion teams, any opinions for the feasibility of having N2 motor again?
That we will have to see if we can find better tools. The issue with machining these things is that the tools that are available at the machine shop are constraining us from performing our duties in a timely manner, because the boring tools there have an issue, especially with boring things with a long depth.
Okay. I need to tell you that the N2 motor was using a mild steel as opposed to the aluminum.
The N2 motor?
Yes.
The testing casing?
No, for the actual launch, I remember we were using the mild steel, and I think we didn't need a boring.
Oh, so since we still have the pipe, in order to avoid boring, we will have to cook smaller grains that will just fit into the pipe and escape the process of boring.
Yes, yeah, I think, yeah, that's in order. So in that case, there is still a possibility of having larger grains compared to N2 by using such remaining pipes. Okay, so I cannot hear you,
Larger
Daniel.
grains are
Hello?
lengthwise or
so I'm saying okay, so let me clarify what I'm saying. So for 2,000 meters or N3 motor, it's let's say this is N3 motor, and SRM casing we are using aluminum. A grain is 5 grains. Is it 4 grains? Yes, yes, 4 grains. Yes. So what I initially thought was we are going to use N2 motor, which has a mild steel. Like this, so that we have, was it 2 grains? No, it should be 2 grains. Okay, so that was my assumption. But how about this? Like N3 motor, N3 motor, I don't know, prime, N3 motor prime, so that we have a mild steel pipe still, but we have 4 grains or 3 grains. Is it possible to redesign?
We have the necessary raw materials to make a casing which can hold 4 grains.
Mm-hmm.
So it's all a matter of rescaling how we are going to cook the grains so they fit into the pipe without boring them.
Okay, okay, I got it. So maybe the suggestion is that we would aim, okay, ship 2,000 meters or less, because if we use mild steel pipe, it would be heavier, so our apogee will be affected. It should be decreased, I suppose. But if it's possible, and if you can satisfy the strengths, the required strengths using a mild steel, yeah, we can still use the 4 grains. Yeah. Do you think, is it feasible to develop or create 3 of them?
It's feasible, but I will have to talk with the members. As I've seen, Collins has raised his hand. Maybe let's hear his input before we can plot a way forward.
Yes. So Collins, welcome. Collins, go ahead. He might have some issues.
If then the necessary materials for making 3 of such casings are available.
Mm-hmm.
And as I've said, the only thing that's going to change is the diameter of the grains we are going to cook. So producing the casings is available, and we'll have to look into the matter of the mild steel blocks so we can create 3 more nozzles, because at the moment we only have 2 functioning nozzles.
All right. Okay. 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 So for fabrication of the nozzles, do you have any concern?
Fabrication of the nozzles is an easy process, which if with the available manpower, we can do possibly even 2 a week.
Oh, that's great.
It can take at maximum 3 weeks to fabricate the 3 that we need.
Okay, this is noted. Yeah, then I think, so in your team, could you discuss the feasibility of having the customized, motor, N-3 motor, and then clarify the, if it's possible, kindly get a quotation for the tools, the boring tools, which has more efficiency, because you are still working on the remaining SRAM casing, which has aluminum material. And then based on the change we would need, because basically we are redesigning another motor, right? So we have to create, we need to make a simulation with open motor. So hopefully by Sunday, could you work on it and share your result?
Okay.
Okay, thank you. I'm seeing Anne is raising, so please go ahead.
Good afternoon. I have a little concern or maybe a clarification from your side. With the 2,000 meter or less apogee, does that mean the airframe team needs to come up with a new airframe to suit that apogee, or are we still going to use the same airframes that we have made already?
Yeah, thank you. So we don't adjust the airframe. What we adjust is a solid rocket motor. So essentially, it doesn't affect the airframe. As far as it can be attached to the airframe. So open rocket simulation needs to be done again. But what we do is that we just remain the current airframe design. Then we replace the motor. That's why I'm requesting the solid propulsion team to work on the open motor simulation to generate the thrust, profiles. Is it clear?
Yes, that's clear. Thank you.
Yeah, thank you very much. And I'm seeing the message from Dr. Mushiri. Simulation can be done to establish new apogee when using mild steel. Yes, that's correct. Thank you. Okay, so let me quickly go to the another topic, which is the PCB. So I need input from the recovery team. So okay, maybe first question is how many PCBs we are going to fabricate for each rocket? Anyone from recovery team? I'm asking because there should be some functions like ejection and the telemetry. Flight control can be done, it should be discussed separately, but essentially we have ejection and the telemetry and logging, Kalman filter. So is it possible to achieve it in one single PCB, or do you have separate PCBs? So this is my question. Any input? Yes, please.
Hello. Hello.
Hello.
Speaking. I'm Samson. I was in recovery in the last batch.
Yes.
So in terms of PCB, the ejection PCB must be totally different since we are passing around. Yeah, since it handles more voltage, more than the microcontroller can handle. Then telemetry, flight control, the others can be on one PCB. So, and we also have another PCB for power distribution. So by now we have 3 total PCBs, one for ejection, one for telemetry, and one for the PDB, the power distribution board. That's what we are working with currently.
Okay, thank you very
We
much.
don't have a PCB for flight control, so I don't think it's necessary. I don't think we'll be adding it to N3 since we don't have flight control mechanism.
Oh, okay. Yeah. Thank you. Yeah, this is then update. So one rocket will have a flight control system, which is active fin control, a tail fin control. So in that case, I think, yeah, Bob is here. So Bob is working on his final year project. So, okay, I mentioned we don't change any airframe, but it should be changed. So one airframe must have active tail fin. So let's say rocket number 5 will have active tail fin. So yeah, it becomes like this. Yeah, I'm putting the number of PCB. So from number 1 to 4, they don't have any PCB, but the last one will have another flight PCB. Or okay, this should be discussed because yeah, I was discussing with Bob that if we should have a separate PCB, and in case we can have we can integrate his code into the flight controller, yeah, we can reduce. We don't need to create the independent PCB. But the okay, another question to airframe, sorry, the avionics team is that are we going to have a separate PCB for the logging? Or is it the same as telemetry?
Okay, for the drone test, we discovered that the ESP32 comes with enough flash for such that we can log the data directly on the ESP. But just as a precaution, we'll also log the data on our flash memory chip. So yeah, we were debating logging it on an external chip. It increases the number of processes the code has to run through. So it kind of will slow down the code a little, though. We've not yet done the calculations as such. But for data logging, we can log it directly on the ESP. We tested it during the drone test and it was successful.
Okay, good. So I think in my understanding, so one PCB for integrating telemetry and sensor data acquisition and sensor data logging. Am I right?
Yes, one PCB does all that.
Okay, thank you. Okay, so the question is going to the recovery team. So how many PCB have you made? So apart from this, you have to create a 5 times 3. It's 15 PCBs. So out of 15 means 3 times 5. Okay. So how many PCBs have you made so far?
We only had, we had one of each. We have one ejection PCB, though I need to state that there's an issue with the current ejection PCB since during the POP test for ejecting the parachute, we discovered that it takes quite long. Once apogees detect, it took about 1 minute for once the signal was given until the parachute was ejected. it took quite a while. So the ejection PCB, the one that we have currently, we'll have to redesign a new one. Though we had one of each. We had one PCB for telemetry, one for ejection, and one for the power distribution. They were all made locally. Though for the final PCBs, they'd be professionally manufactured. Preferably, maybe something like JLC PCB, and we order them to come in. So yeah, that's the update for the PCBs.
Okay, thank you very much for your update. So you are saying the PCB ejection PCB is not completed. I mean, the design is not completed. Still need a modification, but the others too, it is already completed. Am I right?
Oh yes, sir. And I need to also add that for video transmission, we are using the Pi.
So we need to have another one.
Yeah, for video transmission. A Pi and a camera. So
okay, so I think we need to make a decision, because in case we are going to fabricate the PCB using a supplier like JLC PCB, we need to count the lead time, like 1 month and so. And since we are almost having 2 months, okay, and if we want to place the order, we need to do it immediately. But are we ready?
Maybe ask me that again in a week. I'll have the answers. So since yeah, we will sit down and discuss with the recovery team for any changes before. But for now, we are not yet ready to make the order.
Okay, I understand. So the advantage of having a PCB, which is made locally, is that we can modify or update or debug the hardware just before the launch. And disadvantage of having the JLC PCB is that we cannot do it. So if we are going to continuously improve something, we might need to work with the locally made PCB. Or any other possibility is that we are going to use the independent ejection PCB made locally, and we'll have independent JLC PCB for other functions. But anyway, I think avionics team is going to discuss this issue, then share the conclusion in the next meeting. Okay, so, and it is also, it concerns with the final year projects, because definitely some of the codes and some of the hardware must be integrated. So, so I think we don't conclude this one in this meeting, but for the final year project students who are working on the N-3 topic, who are here, like Bob, Jones, Ruth, Safa, Stephen, and Jun, please consider which one you want to place it. Maybe the thing is that if you have a concern of interference, for example, if you don't want to integrate the telemetry system with the active tail fin control, it must be separated. So maybe think about such interaction and decide which rocket you are going to use for your final year projects. All right, so this is something we are going to complete in a few days. Then another announcement is that we need to identify who is traveling to Isiolo. So this is just a list of the participants. So kindly put your name if you intend to join. So tentatively, it is being planned on the late November. And then the next tab is talking about the remaining tasks. So we want to, okay, this, essentially we are going to do the same in the GitHub projects. So, so if we utilize this one, this sheet may not be required, but I think it's better to have something in one page. So I just create it. Yeah. And finally, okay, this is just a tab for encouraging our discussion, because sometimes we might forget or we might oversee some issues we have discussed. So just to keep our focus, I created the sheet to track the question and the answer. So I hope this will help the understanding of the members. So because there are some members who are absent today, so they can see this question and answer sheet to catch up. Okay, so in conclusion, we have a next meeting on Sunday. I propose to have it on Sunday, 5 p.m. And we are going to finalize this spreadsheet and also the tasks. So all the tasks which will be done before the N-3 launch should be listed on the GitHub issues. And it should be also visualized on the GitHub projects. So let me also create another project, which is N-3 launch. N-3 launch. Yeah, I need to create. All right. So do you have any questions so far? Any clarification? Okay, another thing is that I understand that most of the students, most of the members are already back in session, but there might be some students who are not and who may have time, who can work as full-time. So maybe if you find someone, please let me know so that they can assist us. Also, yeah, so I think that's basically about it. Any final comments? Samir, do you want to say something?
Yes, thank you. I just wanted to say I have messaged Dan, the solid team lead. I have asked him if we can go to industrial area sometime so that I can show him the shops around, and if he can come with a sample of the tool or even maybe pictures or something, we can move around the shops and try to see if we can find the tool as preferred by the technicians.
Okay, thank you very much, Samir, for your advice. Oh, and I forgot to mention, we need to identify the names for the rockets, 5 rockets. So last year, we have used the name of the river in Kenya. So in the next meeting, we are going to also discuss it. All right, any comments, any questions? Okay, so if you have any questions, if you need any clarification, don't hesitate to ask on the WhatsApp group. So I want to re-energize the discussion in the forum. So let's utilize it as much as possible. So if you don't have any other issues, we can close the meeting here. All right. So thank you very much for your participation. I'm going to upload this recording on YouTube so that other members can follow. So thank you very much once again, and have a nice afternoon.
Same to you.
Thank you.
Thank you.
You too.